Okay students, what is second law of Newton? Well, first thing you need to know is, it says that net force on a particle, the net force on a particle is equal to rate of change of its linear momentum. So the net force on a particle will change its momentum and it will be equal to rate of change of linear momentum. But how do we calculate rate of change of something? How to calculate rate of change? So think about it. Let's say there's a boy and in 3 years of time, his height increases by 6 inches. So in 3 years, he becomes taller by 6 inches. Now, if somebody asks you, what is the rate of change of height of this boy? Then you will say that he grew by 6 inches over 3 years. 6 inches over 3 years tells you that he grew by 2 inches every year. Okay, so 2 inches per year is the rate of change of height. Similarly, you can calculate rate of change of anything. In this case, you want to calculate force, and force is rate of change of linear momentum. So what do? You calculate change in momentum just like you calculated change in height and divide it by time. So you calculate change in momentum and then you divide it by time. So how do we write change in momentum? See, the change in anything is final minus initial value. So final momentum minus initial momentum. We can write final momentum as mass into final velocity. We use V for final velocity. So mass into final velocity is final momentum minus mass into initial velocity is initial momentum. So this is final momentum minus initial momentum divided by time. If you take the mass as common, assuming the mass doesn't change, which will not change in 99% of cases. So as long as mass remains constant, we can take it as common. It will be velocity V minus U upon T, final velocity minus initial velocity upon time. Now you should know that this is nothing but rate of change of velocity, how fast the velocity is changing with time. And that thing can be written as acceleration. So theoretically, net force is rate of change of linear momentum. But for practical uses, you can write net force equals to mass into acceleration. Is that